On this episode, we're regulating voltage. Hey everybody, welcome to episode 15 of DailyIoT. My name is Kevin, I am your host, and today we are talking about solving a problem that we've got on the scooter projects. And so, if you remember, we've talked a little bit about controlling the motors on the scooter, and we've talked about the electrical system and some of the inputs and things like that. What I want to talk about today is how do we actually get an IoT platform onto our scooter? And there's a specific problem that we have to solve, and that's of system voltage. So on both of the scooter projects, both the one that we have going on at work and the one that I have here in my garage, the batteries are currently two sealed lead acid batteries on both of them. And these are 12 volts apiece. These are actually spare batteries for the work scooter. The ones in my scooter are actually twice as big, but they're 12 volts, they're wired up in series, and when you wire batteries up in series, you add the voltages together. So that creates a total system voltage of 24 volts, which is what we need to drive the motors on those. I'm gonna put these back down. Okay, however, we want to strap an Internet of Things platform to these scooters. That could be in the form of, there's a particle photon, I've got an Onion Omega here. You know, you could slap one of these on a Raspberry Pi, an Electron, an Arduino, a chip, a Flutter. I haven't talked much about the Flutter, maybe in another episode. But one of those platforms which is not going to want to run at 24 volts. You can't just plug 24 volts into an Arduino and expect good things to happen. In fact, bad things will happen. You're going to release the magic smoke from that Arduino, or any other platform for that matter. They're just not meant to have that system voltage put into them. And so that's a problem that we need to solve. We want to attach one of these platforms to the scooter, and we need to power it appropriately. So how do we do that? Well, we have a couple of options. Right off the bat, we could do something like battery power. This is a little USB battery pack that will output 5 volts here that we could plug into our platform. So we could strap one of these onto our scooter. But then that leaves us with the problem of not only do we have to charge these giant sealed lead acids that we have, or in the case of mine, the lithium iron phosphate that we talked about yesterday, but we also then have to charge one of these or any other battery pack that we want to use. And so ideally what we'd like to do is take some of that 24 volt, tap into that 24 volt supply that's already on the scooter, and use that to power our platform. And we can do that. We can use what is called a buck converter, otherwise known as a step-down converter. And I just so happen to have received 2 of them from China today. And I can put a link to these. I'm not suggesting you buy them. I have not had a chance to test them. They could be total crap, I don't know. Once we make it that far, I will give you the review. But this is what it looks like. They don't all look like this. Buck converters come in all shapes and sizes. But the purpose of a buck converter is, like I said, otherwise known as a step-down converter, is to convert one DC voltage, a higher DC voltage, to a lower DC voltage. In our case, 24 volts to something below 24 volts. These ones that I bought, I got them for about $7 or $8 off of eBay, will step that 24 volts down to 5 volts, which is perfect going into a Photon or a Raspberry Pi. A little high for an Onion Omega, but they have voltage regulators that can fix that easy enough. And so that's what the purpose of a buck converter is. Now, I just want to make a quick note. Sometimes I'm not predicting, but I'm sensing I might have gotten what I paid for on this. These things can range from cheap, like I got here on eBay, to 30 or 40 bucks for a nice one. I think you're supposed to believe that this case is aluminum. Maybe it is. It smells kind of funny, and when I touch it, my fingers are starting to turn gray. So, but anyway, the basic principle here is you hook up 2 of these leads to your higher voltage supply, in our case 24 volts, and then out on the other leads you'll get the stepped down voltage, in this case 5 volts. I think it was a couple episodes ago I talked about wire colors and there not being a standard. If you have ever opened up a computer power supply, you'll have seen red and yellow wires, kind of like we have here, in black. We talked about black being a very standard ground, so these are the 2 ground wires. And if you've ever taken apart a computer power supply, there's yellow and red wires in there as well. Yellow is very common to be 12 volts and red 5 volts. However, you have to look at the markings closely on this because it's actually backwards. In this case, we want to hook up 24 volts to the red wire and we'll get 5 volts out on the yellow wire, which we can use to power our Internet of Things platform. And so that's it. I just wanted to talk real quick. This is a very common thing that you would find in systems like this where you have a higher system voltage that you want to take advantage of. So now we only have to charge the one set of batteries. And then we just tap into that and branch it off, step it down using one of these, a buck converter, otherwise known as a step-down converter. And we get 5 volts that's nice and tame and ready to go into our Internet of Things platform. So that's it. That's all I wanted to cover for today. Just an interesting problem that we needed to solve on our scooters, and that's how we're going to solve it. I will get this all wired up. I will do a review on this, not like a formal thing, but I'll let you know if this is a decent converter. Yeah, it had really good reviews, so we'll see how it turns out. So anyway, if you have any questions about that on shifting voltages for a project, or if something wasn't clear, please just put it in the comments below. I am happy to help and follow up. I'll put a couple links down there to help you as well if you want to learn more about that. Otherwise, we should be getting another scooter update here in the next couple days, hooking it up, taking that brake setting off to see if that fixes our overheating problem. So I appreciate everybody watching. Daily IoT, the show where together we're learning all about the Internet of Things, one day at a time.